Okay, the properties of the clay stratum were given as, so they have given the saturated humidity of the soil as 20 kilonewton per meter cube. So Cc value was given as 0.027 and E naught initial void ratio was given as 1.05. So if they have given the Cc value, so then how to calculate the settlement? How to calculate the settlement? So delta H is equal to H naught into Cc divided by 1 plus E naught. Initial height of the clay layer which is undergoing the consolidation, the coefficient of compression index, so which is linear, so it can be used. Okay, it is the slope of the graph which is drawn between void ratio and log to the effective stress 1 plus E naught. Okay, so E naught is nothing but the initial void ratio, so it will log to the base 10 sigma f dash by sigma naught dash. Okay, sigma f dash equal to sigma naught dash plus delta sigma dash. So sigma naught dash is nothing but what is the initial effective stress at the mid of the clay layer, which is going to consolidate, Fine. So delta sigma dash is nothing but what is the additional stress at the mid of the clay layer, which is going to consolidate by means of placing a load at the surface. Okay, so our task, the challenging task would be determining the sigma naught dash and the delta sigma dash with respect to the given question. So fine. So there is an assumption. Okay, so there is a condition. So as far as if it is an end bearing pile, the load distribution will be starting from the end. As it is a friction pile, the load distribution will be starting from L by 3 from the base of the footing. So let it be L by 3. So 5 divided by 3. 5 meter is the length of the pile. Then it would be L by 3. So what is the thickness of the layer which is going to consolidate? So this would be 5 divided by 3 plus 2 meter. 5 divided by 3 plus 2 meter. This is the length of the pile which is going to consolidate, 3.667 meter. So be careful. The 2 meter soil which is lying below the pile is so only that is not going to attain the consolidation. So as the distribution is happening, from L by 3 from the base of the pile, so 3.667 meter of soil is going to consolidate because of the load, because of the 500 kilonewton load which is placed at the pile cap, over the pile cap. So then now the step by step, let's calculate what is the initial effective stress. Del sigma naught. It has to be calculated at the mid of the clay layer which is going to consolidate. So what is the thickness of soil which is going to consolidate? 3.667 meter of soil is going to consolidate. So then if I want to find out what is the effective stress, then we want to find what is the initial effective or initial overburden stress. So which is 20 minus 10. So sigma naught dash. Okay. So sigma minus u. So that's a one layer of soil. So instead of sigma sat, okay, gamma sat, I can use gamma dash 20 minus 10. So what would be the length? The length is equal to 7 meter minus 3.667 divided by 2. The total depth of clay layer is 7 meter. Okay, so the load distribution has to be is going to start from, okay, L by 3 from the base of the pile. In that case, the bottom 3.667 meter of the clay is going to attain consolidation. So in such scenario, if I want to find out del sigma, okay, sigma naught dash, initial effective overburden pressure, so then I want to calculate what is the stress at this level. So which can be 7 minus 3.667 divided by 2. So by simplifying this, I will be getting the initial effective overburden stress, as so 57.65 kPa. My second task is to find out what is the incremental stress at the mid of the clay layer, so which can be calculated by Q divided by B plus Z the whole square. So what is Q? The 500 kilonewton of load is acting. 500 kilonewton load of load is acting. Okay, so then what would be the breadth? So it can be, the breadth is nothing but the outer to outer dimension of the pile. So which is 0.5. This is one more 0.5. Okay, so 0.5 plus 0.5, 0.5 plus 0.5 plus 0.1 this side and 0.1 this other side, which is equal to 0.2, 1.2 meter. The B would be 1.2 meter. So what will be the Z? What will be the value of Z? So the value of Z, is equal to, so plus 3.67. Okay, so as it is starting from this level, as the load distribution is starting from this level, so this is half into, okay, half into 5 by 3 plus 5 by 3 plus 3.67. So let me make it as, so 5 by 3 plus 2 meter, half into 5 by 3 plus 2 meter, the whole square. So this 5 by 3 plus 2 is nothing but 3.667, half into 3.667. So by simplifying this, okay, so 1.2 plus 0.5 into 3.667, the whole square, the 500 divided by the answer will be getting 54.28. 54.28 kilonewton per meter square, whereas sigma F dash equal to sigma naught dash plus delta sigma is equal to 57.65 plus 54.28. So the final effective stress would be the sum of initial effective stress plus the change in, okay, the additional stress which is transmitted by placing the load on its surface, 111.93 kilonewton plus kilonewton by meter square. So by substituting these things in our formula, what is H naught? 3.667. Cc was given as 0.027 and 1 plus E naught, which was given as 1.05 into, so log to the base 10, sigma F dash divided by sigma naught dash. Sigma F dash is a 111.93 divided by 54.28. Sigma naught dash is a 57.65. 57.65. So by simplifying this, okay, 3.667 into 0.027 divided by 2.05, which is 0.048. So into just sigma F dash 111.93 divided by sigma naught dash 57.65. The log of its corresponding value will be getting 0.288. So multiplying with 0.04, right, we'll be getting the value of around 13.83 mm. 13.83 mm. So let's go with the 13.2 mm. Go with the answer 13.2 mm, option A. So here the only thing is you want to remember, okay, if it is a friction pile, the load distribution is happening from L by 3 from the base of the pile. So this point alone you want to remember. Okay, so to solve this type of question, apart from this, all other things are very basic. Okay, nothing to worry about. Anything with respect to this question. So now let's move to the next question. Match the list 1 and the list 2. So the list 1, certain parameters were given: modulus of separate reaction, relative density and strength, screen friction and point bearing resistance, elastic constants. Okay. So in the list 2, the different tests were given. So what are the things we can find out from these tests? For example, cyclic pile load test, pressure meter test, plate load test, so standard penetration test, dynamic bone penetration. So in this, the plate load test is a very familiar one. So from the plate load test, we can find what is the load versus deformation. Load versus deformation. So using this data, I can find out the subgrade reaction. What is the subgrade reaction? Unit load per unit deformation. So the standard penetration method, we can find out the final output from the SPT test is the N value. So using the N value, we have basic correlation to calculate what is the relative density of the soil, what is the strength of the soil. So these two can be calculated using the correlations from the N value. Dynamic cone penetration test. So this dynamic cone penetration test is used to find both skin friction and end bearing. So these values are used for designing a pipe. Dynamic cone penetration test. Okay, in the SPT test, we can find only the bearing resistance. We can't find the skin friction. Whereas in the cone penetration, especially in the dynamic cone, where we use dynamic load. Okay, so we can find both skin friction and the end bearing. That is its application. So here it deals with only the strength and relative density of a end bearing soil, the soil which is lying at the end. So pressure meter. From the pressure meter test, so I can calculate the elastic constant. So these are certain data you want to remember. So from the cyclic pile load test, I can find out, and this from the cyclic pile load test, I can find out the bearing resistance. I can find out the end bearing response for a cyclic load. The modulus of subgrade reaction. So option B. This can be calculated from the plate load test. Whereas relative density and strength of the soil can be calculated from the SPT test, standard penetration test. The next one, the skin friction and point bearing resistance. Let's wait. Whereas what is this? Elastic constant, which can be calculated from the pressure meter test. See, this is a P. Okay, so these two are very common, the P and Q. Modulus of subgrade reaction and the relative density. If you know these two, you can come up, you can select the proper answer. So it's not required to know about the other test. The plate load test and the standard penetration test are the common test. Okay, so you will be having a much detailed information about these two tests with respect to the UG level. So if you know the proper answer for these two options, so you can get a proper answer for this respective question. Okay, so this is how they used to target with match the following question. Okay, out of 4 to 5 data they will give. Out of this 4 to 5 data, only 2 data will be in our level. The other data will be out of the level or out of the box type of question, where you don't have much discussion on those topics. But if you properly know the answer for the areas, whichever were the commonly asked area in the gate, so you can easily get an answer for this type of question. So it would be option D. Okay, the P and Q matches with the 3 and 4. Okay, so only one option is having this corresponding result. So P is equal to 3, Q is equal to 4, and R equal to 1, and S equal to 2. So R in the sense, skin friction and the point resistance can be calculated from the cyclic plate load test. Okay, this dynamic cone penetration test also shows the same value. Okay, don't get confused with all these things. Okay, don't get confused with these things. So just any two, you can match easily. That is the thumb rule you want to follow with respect to these type of questions. You can't expect that you have to have the entire knowledge whatever they are asking in the examination. It's about competitive. So how forward you are. Okay, it's up to you. So moving to the next question. A group of 16 piles of 10 meter length and 0.5 meter dia is installed in a 10 meter thick stiff clay layer underlined by rock. The pile soil adhesion factor is 0.4. Average shear strength of the soil on the sides, on the sides is 100 kPa. Undrained shear strength of the soil at the base is also 100 kPa. So you are supposed to find out a group of 16 piles of 10 meter length. So L equal to 10 meter, 16 piles. So diameter of the pile is a 0.5 meter. So which is resting on a rock. Okay, so the pile adhesion factor. The pile adhesion factor is given as a 0.4, and they have given the average shear strength of the soil as it is a clayey soil. Average shear strength Cu is also average is 100. Cu at the base it is also given as 100 kPa. You are supposed to find out what is the base resistance of single pile. Don't bother about the group. They are not asking about the group. They are just asking you about the what is the end base resistance. So then Q is equal to QB alone. Don't add this QS. It is base resistance alone. This is not required. So QB is equal to AB into FB. Area of the bearing area. Bearing area into the bearing resistance. Bearing area. Nothing but the cross-sectional area. So pi by 4 into dia square. Okay, bearing resistance would be C dash into NC. So the cohesion of the soil at the base of the pile was given as 100, and the corresponding bearing capacity coefficient of bearing capacity factor. So for a pile it has to be 9. So this value you want to remember. This 9 they won't give at all. If you simplify this, you will be getting an answer of 176.71 kilonewton. So it is option D. So these are very simple. Okay, don't get confused. So this is the term they have placed here, the base resistance of a single pile, and they have given clumsy of data. So they have given the alpha value. So what we'll be doing? We'll be just adding it. So AS into FS. So pi D into L into alpha into C average. So we'll be doing this operation very quickly. So be careful. They have just asked the base resistance. They have not included the side friction. Moving to the next question. For the same question, second bit. Assuming 100% efficiency, the group side resistance is dash. So what is efficiency? Efficiency is equal to load carrying capacity of a group pile divided by N into load carrying capacity of the individual pile. So the group side resistance, they are just asking the side resistance. So here QI is equal to QS alone. So from here it is AS into FS. Is pi dia surface area into length into alpha into C average. So pi diameter is given as 0.5 and length of the pile was given as 10 meter, and the adhesion factor was given as 0.4, and the average cohesive strength was given as 100. So by simplifying this, so 3.14 into 0.5 into 10 into 0.4 into 100. So we'll be getting 628 kilonewton. So then substitute here, so efficiency equal to 100, let it be 1. So load carrying capacity of a group pile, number of pile equal to 16, and the load carrying capacity of individual pile is a 628 kilonewton. So by simplifying this, the group load carrying capacity of the given group of pile is equal to 10,048 kilonewton. So let me go with the option B. So be careful. What is the word they are using? Just they are asking the efficiency or the efficiency of a group bearing resistance or a side resistance. So they have segregated these values and they have just asked the final efficiency. Okay, the final load carrying capacity of a pile group. So next question. The negative skin friction in a soil is considered when the pile is constructed through a it is obviously the same, simple, and it is a fill material. When we are inserting the pile along a fill material, what happened? The fill material has a tendency to settle. Okay, the settling of this pile, the settling of this fill material soil will lead to negative skin friction. Okay, so apart from that, the dense coarse sand, dense fine sand, over consolidated, all these are in the dense state, compact state. So the tendency of this soil, the compressibility of these soils were very less. So all these are dense sand and over consolidated clay. So these are in the dense state whose compressibility, ability to compress, ability to settle is very less. Compressibility is very less. So in this case, what happened? So the settlement of the soil will be less than the settlement of the pile. So this is the condition where we can neglect this negative skin friction. So in case if the settlement of the soil is more than the settlement of the pile, what happened? The negative skin friction prevails. So this is the condition which has to be avoided. So this condition arises when the surrounding soil is a filled soil. Moving to the next question. For a soil profile shown in the figure below, the minimum number of precast concrete piles of 300 mm dia required to safely carry the load for a given factor of safety is 2.5. So is equal to dash, is equal to dash. Okay, Q safe equal to, so Q ultimate load carrying capacity into factor of safety. So I want to calculate what is the ultimate load carrying capacity. What would be the ultimate load carrying capacity? So Q safe is equal to N into load carrying capacity by means of bearing and by means of skin friction. So Q safe can be calculated as the load. What is the load applied? 5000, and factor of safety was 2.5. By multiplying this, we will be getting a 12,500 kilonewton. I want to justify how many number of piles are required to safely transmit 12,500 kilonewton of load. So 12,500 kilonewton of load can be transmitted by n number of pile whose load can be end bearing capacity and the friction. Okay, the frictional capacity. So the how much quantum of load can be transmitted at the end or at the base of the pile, or how much quantum of load can be transmitted along the surface of the pile by means of friction. So whereas what is the formula to calculate QB load carrying capacity? Okay, the load transmitted by end bearing would be the product of cross-sectional area of the pile and the bearing resistance. So whereas QS is equal to AS into FS, surface area of the pile into frictional resistance. So N into, so AB is nothing but, so what is the type of soil it is? It's a clay soil. So the type of soil, okay, the type of formula for FB and FS, okay, bearing resistance and the skin friction resistance depends upon the nature of the soil. If it is a clay soil, then the cohesion values will be influencing. If it's a sandy soil, then the angle of internal friction and the corresponding effective stress will be influencing. So with respect to given condition, it is a clay soil. So then it would be cross-sectional area pi by 4 into diameter square. The FB would be C into NC plus AS is pi cross-section, sorry, surface area. So perimeter into length, whereas FS is adhesion factor into C average. So from here, so the cohesive strength of soil lying at the base was given as 150. The cohesive strength of the soil along which the face of the pile is running is 100. So N into, so the N bearing resistance, what is the dia of the pile, which was given as 300 mm, so 0.3 square into cohesion of the soil at the base of the pile, which was given as 150. Be careful, so you will be failing at this level. Into NC is 9, so pi into diameter is 0.3 meter and the length of the pile was given as 10 meter and the adhesion factor was given as 0.57. Okay, adhesion factor, so length is 10, adhesion factor was 0.57. So then average cohesion, okay, the cohesion along the length of the pile, it was even and the value is equal to 100. So by simplifying this, we'll be getting N into 632.32. So from here, by further substituting or further simplifying this, we'll be getting N is equal to 19.77 is equal to 20 numbers. N is equal to 20 numbers. Option B. So have a clarity before start solving such type of question. Don't get confused at this level. Okay. 5000 kilonewton of load is acting on the pile, then what will be the safe load carrying capacity? You have to multiply this with the safety factor in such a way. I want to design the pile that I have to imagine that the design engineer has to imagine that the the pile has to carry a load of 12,500 kilonewton. Okay, so that is the safe load carrying capacity of the pile. Moving to the next question. What is the ultimate capacity? What is the ultimate capacity in kilonewton of pile group shown in the figure, assuming the group fails as a single block? The entire group fails as a single block. So we have to assume in such a way. Okay, so this is a group of 4 number of piles. This is a group of 4 number of piles. So where the failure is happening along the surface, where the failure is happening along the surface. So such type of a block failure might arises. So then you want to find what is the length and what is the breadth of the corresponding block. The length of the block is equal to the center to center distance between the pile, which is 1.2 meter, plus, okay, here if it is a center to center distance, then we'll be finding another off dia of the pile and here another off dia of the pile. So 1.2 meter, off dia is nothing but 0.4 divided by 2 into 2. So whereas length of the block which fails is 1.6 meter. As it is a symmetrical, the B will be also same, 1.2 plus 0.2 into 2, which is equal to 1.6 meter. So whereas here we can calculate the general formula to calculate the length is equal to n minus 1 into spacing plus dia of the pile. So this is how we can calculate the length and the breadth of the block about which the failure is going to arise. So by using this, length and breadth, so I can go. What is the type of soil? The type of soil is a clay soil. So whose Cu value is 40 kilonewton per meter square and the length of the pile is 10 meter. So let me simplify this. The ultimate load carrying capacity. Okay. So the value at which the group files. So let it be Qg is equal to. So the bearing resistance and the frictional resistance. As usual, AB. Okay, it's a product of the area under the resistance. Similarly, Fs into As. So as it is a square, B into B. So 1.6 into 1.6 into C into NC. FB is equal to C into NC. What is C value? The C value was given as 40. NC is equal to the bearing capacity factor, which was equal to 40. NC equal to 9 plus AS is equal to 2 times of length plus breadth into height of the pile, length of the pile. So 2 into 1.6 plus 1.6 into height of the pile was given as 10 meter. And so Fs is equal to alpha into C average. So for group pile, alpha is equal to 1. So C average was given as 40. Okay. So by simplifying this, we will be getting a value of around 3481.6 kilonewton. So this is the ultimate capacity of the pile, which is failing by block failure. So this is the load carrying capacity of the group pile, which is failing by block failure. So moving to the next question. A pile of 0.5 meter dia and of length 10 meter is embedded in a deposit of clay. The undrained strength parameters of the clay are cohesion. C is equal to 60 kilonewton per meter square and its angle of internal friction phi is equal to Cu undrained parameters equal to 0. The screen frictional capacity, so Qs, how much? Whose alpha value was given as 0.6 and its length of is given as 10 meter and the dia of the pile was given as a 0.5 meter. So if it is just screen frictional carrying capacity, Qu is equal to Qs alone. In that case, it would be As into Fs. As it is a clay soil, the area As will be perimeter. So pi d into, pi into dia into length. So whereas Fs is equal to alpha into C average. What is the average cohesion along the length of the pile? So then it would be pi into 0.5. So the length of the pile is 10 meter and the cohesion, okay, adhesion factor is 0.6. The C average cohesion would be 60. So by simplifying this, 565.49 kilonewton. So let me go with option